So hello guys, we are here today to talk about our use case on CTS Hackathon. So we are team 13 members. I am Tarun and my other team members are Deepak and Kavin here. So we are going to talk about the overall overview and the workflow of our project, which is AVA. So AVA is nothing but a patient help desk assistant. So as you can see, we can go through the overview here. So these are our project's objectives: booking appointments or displaying reports or sharing their patient history, etc. But only such assistants are needed for automation. So the answer is no, according to now, because most of the hospitals or patient help desk assistants lack patient experience. Okay, so what is patient experience? So patient experience is just like user experience for an app. But patient experience is a term used for hospitals. It is a term which is used to denote the satisfaction of patients when they are utilizing the hospital's resources and care. So patient experience now matters more importantly because there are a growth in healthcare providers day by day, and also people have the choice of selecting their healthcare provider. So to retain the competitive market, hospitals aim to achieve more patient experiences from their patients. So our solution AVA is all about an patient help desk assistant, which aims to secure most of the patient experiences or to enhance existing patient experiences by adding an intelligent feature or let's say the enhanced personalized feature. First, it may help to us like more in a personalized way, and it has intelligence than more of the existing solutions here. So the features will be explained by my teammate Kavin.
So the features of AVA are to automated alerts to patients on medications and consultations to and retrieve patient records to predict optimal consultation timings in heavy hospital situations to generate a smart report, a general inquiry chatbot that can answer user general questions for personalized automated feedback collections, and to check if the user is eligible for any government schemes. Consult time arrival prediction is basically in a busy hospital situation, it will tell the user which time would be optimal for them to come and meet the doctor and finish their consultation. So now I will share the uh, tree diagram for the chatbot. Diagram for the chatbot. So basically, how the rule-based chatbot works is that first it will greet the user, then it will ask for what type of queries does the user have. For example, general information, doctor availability, visitor information, and contact information. So
Hello,
if in the case that the user selects general information,
Kavin, can
then it
you
will,
zoom a little bit?
okay. In the case that the user selects general information, it will then prompt the user to for their question like department, services, hospital hours, location. If the user selects hospital hours, it will tell about the opening and closing of the hospital or the services that the hospital provides, the location in which the hospital is located at. So it goes for every information. It will basically answer every information or query that the user has. Now I will hand over the session to my teammate Deepak.
Thank you, Kevin, for introducing. Let's see. Hi, I'm going to introducing non-AI features. In non-AI features is in a general inquiries and a healthcare event alerts and automations and government scheme eligibility checkup sit- systems and a patient's records history. Next slide, please. Yes. In general inquiries, we are going to see about as an AVA handling outing patients about services, facilities, or and a general advice, providing a quick associated response with a human interactions. Ensure the patient satisfaction by offering the instance easy to use and supports. Would be a post treatment supports. AVA provides a personalized follows up and messaging to the patients after their treatment, remembering them of an medication schedules, upcoming the appointments, and self-care tips, ensuring the conditions of an care of ensuring the patient's recovering and reducing the likelihood of an complications by keeping the patients informed and support during their recovery period. Next slide. A patient records history. AVA provides a comparison views of a patient historical data, including a previous treatment, mm, medications, and outcoming to help to track their progress over time. Enable better understanding of the patient history, supports informed decision making, and improving their consistency of caring by giving healthcare provides as a, as a phrase of a past treatment. The next is a government scheme eligible checker. Our assistance patients is determining the eligibility for a various government schemes such as insurance and healthcare services by analyzing their personal and medicine information. Next, these are a text tags. In our we are being
Here I'll explain the
is a
discharge report
non-AI feature for
generation,
involved
and let me
involved
start with the workflow
parties.
first.
In
And
ML
I'll say how
models,
it
we are
efficiently
using in a
uses
front end.
various data sources to provide a
In a
patient
back
friendly
end, we are
report.
using flats.
So basically, this
For
flow
chat
ensures
box, we are
all
using
those necessary
event box.
information, such as
For
you
this
see
is
the
are be
patient
involved in
visit details and
text
all those
tags.
symptoms and also
Thank you.
the doctor's recommendations.
Ashika, you
So
may speak now.
basically, we crafted this in a way that all the details are pulled together and it produces a seamless report together. So the process starts with an input, which is the visit ID. So this identifier helps fetch all the relevant information about the patient from all the different data tables. So it also makes sure that all this detail from the patient's past and the current visit is included in that final report, which is to be generated. So next to the patient table, which holds information about the patient, such as their name, age, and the medical history. So once the visit ID is passed inside, so the system retrieves all this data about the patient. And next, the system accesses the appointment history table, which holds the details of the current visit. So it includes the date, cause of the visit, symptoms, and any medications that is prescribed by the doctor. So at the same time, the system also pulls the doctor details from the doctor table. So it includes the doctor's name and ID. So once all the information is gathered from the patient, appointment history, and the doctor tables, the system generates a detailed report. So this report explains the reasoning behind the patient's condition and also its prescribed instructions, which is by the doctor. So finally, the generated report is presented as the output, and this document helps patients understand their health better. So this entire flow works efficiently by pulling all this data from multiple sources and databases, as you see, and we just combined it to a comprehensive report. The integration ensures that the report is accurate and complete, and basically this is to help the patient because this is patient friendly. And let's get towards the integration part. Okay, so now I'll walk you through how I've integrated the model. So basically we use Gemini for this, and first we have installed all the necessary libraries that needs to work with it. And the next step is to configure the API key. So this helps our website to communicate with the Google's generative model. And we got a unique API key which I've configured right here. So this is very important because it authenticates our access to the Google's AI platform. And now we are going to set up the model and a generative model. So we adjusted certain parameters here like temperature, top P and top K, along with max output tokens. So as you can see it in here, and these parameters help ensure the AI generates response that are accurate, detailed and suitable for medical reports. So to guide the as you can see here, system instruction which is concise and precise and all those instructions. So to guide the model on how the output should look like, we provided such an instruction. And this is the most important part, which is feeding the patient's information to the model. And here's the data. So we pass this data into the chat session to generate the discharge report. First, we'll initiate a chat session, which is empty at first, and then we'll send the patient's data as used.
In this project, we have developed a predictive model using random forest regressor to estimate optimal consultation time for appointments. We have created the model using Python code. This is the Python code for optimal consultation time. The appointment start time and optimal consultation time columns were in hours format. It is converted into total minutes for complementing ease. This allows us to perform regression on continuous numeric values rather than the time string. The input features includes total slots, total available appointment slots, your slot, number of booked slots before your slot, number of empty slots before your slot, and average consulting time and appointment start time. We have splitted the data into training and testing sets using 80 to 20 splits, ensuring that the model has a balanced distribution of data to learn and evaluate. We used a random forest regressor with 100 estimators and trained the model using the training dataset. Random forest is chosen for its ability to handle both numerical feature and nonlinear relationship effectively. Mean absolute error. This measures the average magnitude of errors between the predicted and actual data. Mean squared error. This metric gives higher weight to larger errors, in helping identify the significant deviations. And R squared error. It reflects the proportion of variance in dependent variable explained by the independent variables. So here we have given the input data for consulting for a new data. This model's performance shows potential for optimizing appointment scheduling by accurately predicting consultation times, reducing wait times, and improving operational efficiency in healthcare.